screen visible. Okay. Now let's begin with Ltspice window and click on the new schematic. I hope all of you have got this blank screen. Maybe your screen might be a little gray or different color, right?
Yes, sir.
Okay. So to set the screen to white color, because it is required to upload it, right? The print screen. So go to tools, then go to color preference. In the schematic window, go to background. In your case, it might be nearby in 200, right? Make it 255, red, green, and blue. So you will get a blank screen, white screen, and click on OK. Okay. Is the screen color changed? Background? Anyone has tried?
So can you repeat?
Okay, go to tools, go to color preference. In that, select the schematic. Then in selected items, select background and move everything to 255. You can move this pointer, red, green, and blue to 255 and click on OK. So did you all get the white screen? Yes.
Yes, sir.
Okay. Now right click over it. In the view, click on view and click on show grid. Okay, press show grid. So this dots, small dots will come. It will help you to, make the circuit properly. So can we start?
Sir, will you be providing this recorded lecture?
Yes, I will be providing. Don't worry. Okay. Can we start with the simulation, please? Hello, everyone.
Yes, sir.
Okay. Now let me take a complex circuit, circuit like this. Okay, this we have to find current through 5 ohm resistance by nodal analysis. Now this Ltspice software, it supports all the linear resistors, dependent current sources, independent voltage sources, right? So we can easily apply, any linear circuitry, and we can find out the results in seconds. All right. So let me take this example. I hope the circuit is visible to you, right? Everyone. So
Yes, sir.
if you are doing hands-on, then you can repeat the steps what I'm doing over here. All right. So listen carefully. We are going to make this circuit in the Ltspice schematic. So over here we have this kind of a symbol. Click on components. Click on components, or you can even go edit and then click on components. It one's and the same. Done. Then if you want to select a voltage source, type over here voltage. Type over your voltage and press enter. So the moment you press enter, it will wobble around. Now, if we have to rotate as shown in the right hand side screen, the voltage is reverted. So press Ctrl R to rotate the supply. Press Ctrl R and tap once in your mouse pointer and then press escape. Understood this step? Yes. I repeat again, we have to go to components, type their voltage, then click OK. And in order to rotate this, press Ctrl R. Are you able to achieve this? Quick response, please.
Yes,
Yes,
sir.
sir.
Yes.
Yes.
Yes. Okay. Now, do you see this nearby? If you go left hand side, 1, 2, 3, 4, left hand side 2 components, you have a resistor. Click on that. And in order to place it, tap it once. So it's got placed. Now, if we want to place it more, then keep on tapping. One, I require one over here, one over here. And in order to rotate, press Ctrl R. So I've rotated it. Now I tap once. Don't tap it double, or else the numbering will make sure that only register is tapped only once. And then press escape. So R1, R2, R3, R4, R5. Automatically it came. Do you want me to repeat or this is fine? Hello.
Sir, can you repeat once?
Okay. Yeah, register part, right?
Yeah, yeah.
Okay. So here is the register over here. So if you want to place a register, you put one tap. You have your mouse, right? Put one tap, one click like this, one click. Then in order to rotate, press Control R without clicking. Then click in order to place it. All right. Now, if you want to move any component, let's say I want to move this register. So I select this move button and click on it and I move this register over here. I can move it anywhere. Okay. Is this clear up till now?
Thank you, sir.
Yeah.
Also, can you
Now,
tell again move one?
yeah. So I click on move and then I click on this register. I can move it anywhere and then click once to place it onto the schematic. Done.
Okay.
Yeah. Now we have to select. Now there were 1, 2, 3, 4, 5 registers, one voltage source and two current sources are there. To select a current, go to components and type over there current. So type current. One current source, I will place it over here. Another current source, I have to rotate it and place it over here as per the given diagram on the right hand side over here. Okay. This is solved numerical which I have taken. So to verify the answers, this much is clear. Everyone is able to do this much.
Yes, sir.
Okay. Now we have to connect them with the wires. So here is a wire. I select on it. Wherever you want to start the wire with, click once and then drag the wire. Then click again. Then again drag the wire. Then tap it. Okay. This way you need to connect. Let me just show it again. Let me show the wiring again. Okay. To connect on the wire, click on the wire. Let's say I'll start from here. Tap it once. Then in order to bend it, click tap once more. Then in order to connect this, you can connect all of them together or you can connect them one by one. So wherever I want a bend, I will tap click once. And finally, I'll connect it over there. Did you understand how to connect the wire?
Yes, sir.
Okay, so do it please. Here also I want to do it. Click only once like this. So whenever two or more wire meet, there will be a this kind of a rectangular box created. So that means the wires are connected. Okay. Now I have to connect one more wire over here. All right. So whenever your circuit is ready, as shown over here, let me know. I'll continue. So all of you are ready?
It's 1 minute, sir.
Okay. I guess in your assignment you have Thevenin's and Norton's theorem, if I'm not mistaken, right? In your IA1,
Yes,
you have
sir.
simulation question for Thevenin's and Norton's, right? So remind me to cover one Thevenin's and one Norton's theorem example also. Okay.
Yes, sir.
Okay. Are you ready? Can I proceed now? Okay, now if you see carefully, we have a ground now. Even if our circuit doesn't have a ground, we have to see that where the maximum number of nodes are connected. So the maximum number of nodes, we call it as a reference node. All right. So reference node, we can connect a ground. So here, if you go left hand side to the resistor, we see the ground. So click on the ground, place it anywhere below, and then join it with a wire. It's very mandatory that you need to connect the ground to every circuit. Without that, it will not simulate. Is this clear? All of you ready up till this step? Hello?
Yes, sir.
Okay, great. Now, yeah. Now we will give the value to all these resistors, voltage source and current source. So right click over here, right click on the voltage current source. You will see its DC value. Click on 4. By default, its unit is amperes. So just 4 will be enough. Again, if I want to show it over here, I want to give 8 value. Just I put 8 and press enter. Okay. So I1 is the known the label of it. Okay, of this current source, and 4 is the value. Similarly, R4, R5, R1 are the labels, are the notations. Now I want to give this voltage source 20 volts. So I'll press 20 over here, press OK. All right. This resistor is 2 ohm. So I'll press 2. OK. This one is 3 ohm. Do not enter the unit. It's by default resistor is in ohms. So this will be 2 ohms. This will be 5 ohms. And over here, this will be 4 ohms. All of you are able to understand how to enter the values of a voltage source, resistor, and a current source, because only these 3 components you will be seeing over here in your numericals. Completed? Can I start? Proceed ahead. Hello.
Yes, sir.
Okay. Now, see, in nodal analysis, what do? We identify the node number. So this is my node number 1, 2, and 3. Now I need to label this node and call it as V1, V2, V3. So in order to label the node, right click over here. Let me expand it and show it to you. Right click on this wire and click on label net. And here you can type V1. Okay. So I'll place the voltage over here. I mean the label over here. Then similarly over here and over here. And then later on, I'll right click over here and call it as V2. And right click over here, call this as V3. Okay, so I put the label on these 3 nodes. So V1, V2, V3. What we can do is we can even connect a wire and then do it. It's fine. So I can move this up. So this will be V1. Okay, so this is also possible. Or else you can stick to the technique which I have shown over here. Right click on the wire, click on label net, and you can give any name over here. Okay, that's it. Your nodal analysis. We need to find the current through 5 ohm resistance, right? So we will first find V1, V2, V3 in theory. So all of you are ready to simulate now. We have made the circuit as per the given data, as per the structure given to you. Now we have to simulate in Ltspice. So are you all ready?
Yes, sir.
So go to simulate.
Yes, sir.
In order to simulate the circuit, go to simulate, click on run. Okay. Then click on DC OP point. It's called as DC operating point. Okay. The moment you click on DC operating point, then click on OK. All right. So did you get the screen over here?
Yes, sir.
All right. Now let me highlight the screen. Let me expand this. V of V1. So it's a voltage of node V1. So how much I theoretically I want? Theoretically, I got the value as minus 8.76. See how much we got it over here? Minus 8.76. Okay. Then V2 we got it as in theory we got it as minus 9.92, and here we got it as minus 9.917. That is minus 9.92 only closely. Then voltage at V3 node will be 13.369, and we got in theory as 13.3637 volts. So understood how we can get all the values similar?
Yes, sir.
All right. Now there is one limitation in Ltspice. I'll tell you about a limitation a little later. Right now, we want to see the current across the resistor, across 5 ohm resistor, right? Over here. So across the 5 ohm resistors, we are getting the current as minus 4.65. Okay. So here you see I of R5. So R of R5 we are getting as 4.65. So you will wonder, you will ask why why it is not minus 4.65, why it is plus 4.65. Now this is associated with limitation of Ltspice. There is one flaw in Ltspice which I will tell you. Okay, in order to get the correct current, what we need to do is as follows. Did you understand? We got verified all the answers. Yes or no?
Yes, sir.
So we got the value of V1, V2, V3, and current flowing through R5, which is 5 ohm resistance. And we got all the magnitudes correct. Actually, current direction only will be slightly different. So in order to have a proper correct current direction, what we need to do is see what I will do. So I will use another feature of Ltspice. I'll click this drag. Okay. And I select this part and I just dragged it over there. I'll tell you why I'm doing it. Then I'll delete this part and I'll add if I want to measure the current in a loop, I will add an ammeter. So we don't have an ammeter in Ltspice. Okay. So rather than that, I will add a voltmeter, a 0 volt voltmeter, which will act as an ammeter. Let me connect it and show it to you. So whenever I want a current in a branch or in a loop, I can connect a 0 volt voltage source. So 0 volt voltage source won't, disturb the circuit, but this 0 volt voltage source will act as an ammeter. Now, if I run the circuit again, let me just show it to you. So what I did, I added a 0 volt voltage source. Let me call it as Vx. Okay. This is my 0 volt voltage source acting as an ammeter. Now, if I simulate this again, I'll get all the values correct. Okay. Now, can you see the current? What we want current through 5 ohm resistance is coming out to be minus 4.65, right? Now,
Your mic is off.
Oh, we can't hear you.
hello. When did you stop hearing me?
When you try to change, show that.
Okay. Should I repeat the step about adding the 0 volt voltage source?
No, we hear till that. After that, when you start simulated that circuit
Okay.
again.
Okay. Okay. So, so if I want to find the current now, I want to find current through 5 ohm resistance, right? So earlier when I simulated, I got the value as positive. I told you it's a flaw in Ltspice, which will rectify by adding an ammeter. Now, if you add a 0 volt voltage source, it won't disturb the circuitry. So this Vx voltage source will act as an ammeter. Now, if I simulate this and if I run it again, okay, and if I see the current flowing through this Vx, I of Vx, it will show me the proper current. Okay. So if you want to find the current, you can connect a 0 volt voltage source in series with that resistor and find the proper current. Now, current through 5 ohm resistance is minus 4.65 proper with current direction also minus. Is this clear to you now? Yes. Hello. You have
So
any
I want to
query?
ask,
Yeah.
in which direction we have to connect the VX?
Okay. So the current flows from left to right, let's say. Current flows from positive to negative. So you can connect it this way. If I have connected opposite, then the current would have flown from negative to positive. Are you understanding? Now, right
Yes, sir.
now, in this way, see, minus 4.65, the current is from, can you see the direction over here, left to right? So here also we can connect positive to negative. If I would have connected opposite, it would have been showing you positive value. Okay, so that is also correct. We can write a current negative to positive by changing the direction. So you were asking how to connect this plus and minus, right?
Yes, sir.
So current flows from positive to negative. In this case, Ltspice. So in this direction, you connect it. Okay.
Okay, sir.
And whatever direction you have connected over here, let's say that here it's while solving the nodal analysis. Can you see this I4? I4 direction is left to right. So you connect the 0 volt voltage source like this. Okay. So any problem in understanding this now?
So can you show the zero voltage connection?
Yeah. Okay. So before connecting this, so my connections were like this, right? Correct?
Yes, sir.
So now what I will do, so I can press the zoom full extent to have that full screen. I can zoom back. Now I can connect this drag button. I'll create a rectangle over here and then drag it over here. I want to add in series, right? So I'll cut this wire. Then I'll go to components, type voltage. Now I want the current direction to flow from left to right. So I connect in this in series, connected with a wire like this. And then I can give the voltage as 0 because 0 volt voltage source will not disturb the circuitry. I can name it as Vx. That's it. Now I am ready to simulate. So if I go and simulate, I'll get the correct values of V1, V2, V3, and I of Vx is minus 4.65. Got it?
Yes, sir.
Okay. Now I'll tell you one more thing. Now in your I number 1, you need to upload the print screen, right? So I'll tell you how to upload a print screen. Let me create a Word document. Okay. So if you want to upload the print screen, first of all, you will solve the numerical theoretically. So let's say if this is my numerical, I've solved it theoretically. So I'll paste the entire screen, full screen. Full screen should show date and time also. Okay. So I'll attach the full print screen like this. This is my theory. Just a simple example. Then Ltspice simulation, what I will do, I have to write my name and roll number. So let me write my name and roll number. So let's say that I'll go to view, I go to draft and I go to comment over here. So I'm writing my name over here. Okay. And then space, I'll write my, let's say roll number. So let's say 10023 like this. So you can add your name and roll number like this. All right. Then you can press full print screen, including date and time. And then you can add it like this. Did you understand it clearly? Okay.
Yes, sir.
And in order to show the results, what you do is you click over here, minimize this slightly, bring it over to the left hand side, simulate it, run. Now it's showing all the values, right? But I want to show all the values and my circuit also. So I paste it on the left hand side, expand this slightly, and I can highlight the point what I want to highlight. So let's say this current. I want to highlight this current. This is my device current, and then I take the print screen. So this shows that after simulating the circuit, my current is 4.65753. So this will be my result. Did you understand how to attach the print screen? Okay. Yeah. If you want to add the print screen, then copy this. Some people want to add this in the screen itself. So I'll add to comment. I can add over here device current. So this also I can paste it and then I can simulate. This also can be done. Got it? So this is my current, which is of interest. And I do the print screen. and attach this like this. So as soon as you get the result, you can attach it over here like this. So is this example, understood now? You got all the answers similar? Yes, no? Hello?
Yes.
Okay. So the more you use it, the more comfortable you will get. So let me come to the business end. That is, let me show you Thevenins and Nortons directly now. Another example. Let's see if I have a Thevenins and Norton's theorem. Yeah, here it is. Can you see this example? I hope this is not the example which is given in your IA1. So let me show you the example. We need to obtain the power drawn by 20 ohm resistance using Thevenin's theorem. Okay. And this is my circuit given. So this is my RL. So can we start with this numerical? I've taken a fairly complex numerical, but we can do it easily in Ltspice. So are we ready to start now? Hello.
Yes, sir.
Okay. Now, I would request you to draw along with me if you are working in Ltspice. You can do the connections now. I've already told you how to do all the connections. So let me go to a new schematic. In order to create a new schematic, click over here, new schematic. All right. So let's start building this together now. So I've created a new schematic. I can close the old schematic
So,
now.
so, so.
Yes.
So I have a doubt. So whenever I am creating a new schematic, it's not showing me anything else. It just shows me draft, and there's not any whiteboard appearing.
This one. This one is not appearing. The tool. This section is not appearing.
Yes, sir.
Okay, then in that case, you need to reinstall it. If you still face the problem, then write to me in the email. I'll tell you what to do. Okay.
Okay, sir.
So you might need to reinstall it. Okay. So can we start now with this numerical? Are we ready?
So could you repeat how you got the dots in the background?
Yeah. Right click, view, show grid. Right click, view, show grid. Okay. Or you can press
Sir,
Control G. Yes.
sir, also how to whiten the screen, that one I forgot.
Yeah. Tools, color preference, schematic, selected atoms as background, and make everything 255, red, green, and blue.
Okay, sir, thank you.
Yeah, no problem. Okay, so this left-hand side circuit,
Sir, can you repeat?
What should I repeat?
So the tool part.
Yeah, tools, go to control panel, then go to schematic, select the schematic. Then on the selected atoms, go to background and select the color mix as 255. If you don't select it as 255, it will show you some different color background. Okay,
Okay, sir. Okay.
and click on OK. So can we start with this circuit now? Are we ready? This is using Thevenin's
Yes,
theorem.
sir.
So in Thevenin's theorem, let me not open the document. So there are three things of interest. We need to find RTH, VTH, and actually the current to the load, correct? In this case, we need to we need to obtain the power drawn. Now, I will tell you two techniques to verify the answer directly, and then I'll tell you how to do VTH and RTH. Okay, so can we start? Yeah. So first of all, I require two voltage sources. Then there are many resistors connected, one current source. So let me start by selecting components. Now I'll be a little quick this time. So I hope you can follow it up. So I'll go to components, voltage, I can place it over here. Now I see that my screen is a little big. So I'll click on zoom back. Okay. Now I require two resistors over here. So one resistor will be over here. Another resistor, I rotate it and place it over here. Okay. Then I have one more resistor over here. Then we have a current source. So type current. The current source is in this direction only. Then I have another resistor connected over here and one more resistor which is connected in this direction. I know I am a little fast, but let me complete it and then I'll give you some time to do it. Okay. I'm just doing it one by one, step by step. I know how to select what now. So I'll rotate it by Control R and then I keep on adding the resistors as shown in the circuit diagram. So I've selected all the components over here now. Can you see it? Hello?
Yes, sir.
So one by
Yes, sir.
one, you also try to do the same. One by one, add the components as I have shown. Then after this step, click on the wiring. So do the wiring. So first select the outermost components. So with one tap, connect all of them together. Then I'll do the connections over here. One over here. Over here. Okay. So I've connected the circuit as shown in this circuit diagram on the right hand side. Now I have to just give the values to it. Anyone has completed up till here?
Yes, sir.
Oh,
So
great.
just one question, how to rotate?
Control R. If you select any component, let's say I've selected it, immediately press Control R. And in order to place it on the schematic, one click. Okay. And in
Okay,
order
sir.
to move the next component, move it around. And then I press Escape.
So how do you
Sir,
remove the
how did you
component?
join all the?
How did I join? You with using wires. Let me show the wiring
Yeah,
connection again. See this. If I
like
want to
the
join,
one click one.
yeah, click this. One click, and then it got connected, right?
Okay.
Yeah.
So how do you remove a component?
You have a cut button over there. If I want to remove this register, click on it. Gone. Understood?
Okay. Yeah, got it.
Now I added it back. Okay. Now I'll give the values to all of them. So right click over here. This is 12 volt. Yeah. Someone wants to ask anything?
Sir, how did you get the battery?
Yeah. We go to components, select voltage, type their voltage. You'll get the battery. Okay.
Current and the current one?
Current will be, if you select on the component, type current, you'll get the current source. Got that?
Okay, sir.
Yeah. So now I'll give them the values. So this is 12 volt. Now this will be 2 ohms. Okay. This will be 10 ohms. It's very fast technique actually. This is 20. This will be 4. This will be 5 ohms. This will be 15 ohms. Over here, this will be 25 ohms. Then this will be 8 volt voltage source. And this will be 5 ohm. So all my values have been given. I'll also need to add the ground. So ground is over here. Because without the ground, Ltspice will not simulate the circuit. So I'll connect it the ground. All right. Everyone.
Yes, sir.
Okay. Now, listen very, very carefully. I am directly calculating the current, let's say current flowing through the load. Now, where is my load? This is my load. So let me call this R3 is my load. Okay. Let's assume R3 is my load. Now, if I directly simulate the circuit, it will directly give me the power drawn by this 20 ohm resistance. Now, let me show it to you. Let me simulate. Click on run. DC operating point. Then click on OK. All right. Now, if I see current flowing through R3, I want to find current flowing through R3. So current flowing through R3 is RL actually, right? So let me search I of R3. Here it is. See, I of R3. So how much is I of R3 we are getting? 0.705. As you can see over here. Okay. Are you all listening?
Oh, sir, can you show the grounded, like where did you ground it?
Here is the ground. So you can
Okay.
click on it and then attach it to the circuit. All right. So according to the theoretical answer, if I simulate and if I run, I want to find current flowing through the load. This R3 is my load, 20 ohm resistance. So I need to see what is my I of R3 value. So I of R3 value is coming correct 0.705. Okay. Did you understand how to calculate this? Can you say, can someone
Yes,
repeat?
sir.
Or
Yes, sir.
this we do
Yes,
not
sir.
have to do in, listen. This we do not have to do in Thevenin's theorem. Did you understand what I'm saying? This method in Thevenin's theorem, we should not apply because we are directly finding the current without applying Thevenin's theorem. Did you understand? We need to find RTH, VTH, then make the Thevenin's equivalent circuit and then find the current. Did you, are you all understanding what I'm telling you?
Yes, sir. So we have to make 3 circuits for the Thevenin question.
Exactly. Yes. Because if I find it directly, then I'm not using Thevenin's theorem. Directly, you can find to cross check your answer. Is that fine? Hello.
Oh,
Okay,
yes, sir.
sir.
Okay, now listen carefully, very, very carefully. This is about finding RTH. Everyone has to find RTH or RN. So what do you do to find RTH? Can anyone tell me?
We
Short
short
circuit.
circuit the voltage.
Yeah, I'll repeat once more. To find the value of RTH, we remove load RL and we deactivate all sources. Okay, let me write over here so that it's clear. For finding RTH, so what are the 2 steps? Number 1 step is remove load RL. Okay, then next step is deactivate all sources. So what do you mean by deactivating all sources? Deactivating all sources means if it is a voltage source connected with a short circuit, if it is a current source connected with an open circuit. Got it? Everyone?
Yes, sir.
Now same circuit, listen carefully. I have already verified my answer. But what you need to do is, in order to find RTH, we need to follow these steps exactly. First, make the entire circuit as it is. Okay. Now we need to deactivate the sources. So wherever I see a voltage source, I'll cut it. After cutting it, I'll replace it with a short circuit like this. Got it? Yes or no? Now,
Yes, sir.
current circuit, we open circuit it. So like this, open circuit. So even if you remove it, if I open circuit the current source, it will be gone. So let's remove it only. And I'll open RL. I'll remove the load RL. So this is my load RL gone. Did you understand this much? So these are my points A and B. Okay. We write now point A and B. We need to find the current. Yeah. This is my point A and B. So we need to find the equivalent resistance between these 2 points. Did you understand this now?
Yes, sir.
Okay, now listen very carefully. Again, important step. Now, in Ltspice, we don't have a ohm meter, which will directly give you the value of resistance. So what I will do is, how will I find RTH is, let me write and explain. In order to find RTH, I'll include a voltage source Vx, let's say of 10 volt value. Then I will find RTH by dividing this voltage by the current flowing through this voltage source. Let me explain it by doing it. Okay, this way I guess you some of you all must have not understood. So I will introduce a voltage source of 10 volt known voltage, then I'll find the current through that known voltage source, then voltage source divided by the current flowing through that voltage source will give me the RTH. Now let me show it to you. So A and B, did you understand? Open circuit, this is my load RL which I have removed. Now I will add a voltage source. I'll type over here voltage between the points A and B. Let's say these are my points A and B. Now let me push it up slightly up. Points A and B like this. All right. Now I'll add the voltage source. Maybe I'll cut this a wire a little more. Yeah. Now I'll add a voltage source over here of known value. You can give 1 volt or 10 volt, it's absolutely fine. And connect them together like this. Okay. Now this voltage source, I'm calling it as Vx, let's say, test or Vt or Vx, let's say Vy. And I will give a known value to it, 10 volt. Now, if I simulate the current flowing through this voltage source, okay, if I divide the value of 10 volt divided by the current flowing to it, it will give me RTH. I will show it to you how. So if I simulate now, click on the run button. So what did I get now? The current flowing through Vy. So the current flowing through Vy is minus 1.5 volt. Did you understand this? Now, I'll tell you the flaw which is there in Ltspice. Ltspice considers current flowing into the voltage source as positive. Meaning, if a current is flowing into the voltage source from positive to negative, Ltspice will treat it as positive. But if a current is flowing out of the voltage source, that is, it's flowing from negative to positive, it will treat the current as negative. That is why over here the current is coming negative. So, but in fact, it is not negative. We have to consider this positive value only. So I will copy this part, current flowing to the voltage source. Then I'll add it over here. Just listen what I'm doing. Now, what is RTH now? RTH will be 10 volt divided by this 1.5 volt. Can anyone tell me what is 10 divided by 1.5? Can you do it in your calculator? Is it 6.6667? Oh, sorry.
Yes, sir.
Yeah, see?
It's 6.6667.
Yeah, never ending 6, right?
Yes, sir.
So, and if you see by theory, I've solved it over here. RAB or RTH is coming out to be 6.67. So technique is absolutely correct. Do not worry about the negative sign. It's because of the Ltspice treating the current negative if it is flowing out of the voltage source. Did you understand this technique? If I write over here 1 volt, then I'll get a different value. I'll get 0.15, I guess. Let me show it to you. If I write over here 1 volt, then see what I'm getting, minus 0.15. So then it will be 1 divided by 0.15, which will be again 6.66. Did you all understand this technique of finding RTH? Yes or no? Hello. Can someone reply?
Yes, sir. Yes, sir.
And on every page, whenever you have a print screen, write there question number, which question number you are solving. Let's say question number 1. Then you write your name. Let me write my name and show it to you. Okay. Then leave some space and write your roll number. Let's say this is my roll number. Okay. And font point size, you can keep it same. Attaches like this. And then take the print screen of this. You can take the print screen now. Hello.
Huh?
Yeah. Please keep the. Yeah, please keep the audio off. Yeah. Okay. So are you all following up till now?
Yes, sir.
Now,
Sir,
yeah, 1 second, 1 second. Now, in order to capture this in print screen, after you get everything, after you show this everything, you can write it as it is, as I've written over here. Print screen, full print screen, including the date and time. And whenever you are attaching in that Word document, you can attach it like this. Okay, so this is what we are expecting from you all. And so you have to show this calculation how you got RTH. Is that clear to you? Now you can ask your question, please.
Yes, sir. The RTH value will be same as VNNO3 or NNO2 in your NNO2 6.6667.
Yeah,
Is that
yes. See, yeah, in theory, I'm getting 6.67. Actually, that is also 6 point never ending 6. And this is value is matching with the simulated result. What was your question?
no, sir? It's okay.
Okay. So everyone understood how to calculate this?
So,
Can I?
Just
Yes, please ask. Hello.
yeah. So I wanted to ask, like, for print screen, like, what should we print? Like, total the circuit, na?
See, whatever I've written over here, everything you have to write.
Okay.
I mean, I showed you now how to write it step by step. You have to show how you got the value of RTH and then print screen. Then print screen. Then in your Word document, it will look like this. Okay.
Okay,
So
the
it is,
window also for the.
yeah. Including the date and time. Why I'm telling including the date and time, I'll explain later. But if you do it like this, then it will be very easy for us to correct your answers. We no need to search it. So if you show the circuit and the simulation together, along with these details, we'll directly, check your answers. It will be easier for us to correct. Okay. If you don't include the simulation, we cannot give you the, the rewarding marks, which is devoted for the simulation. Okay. You need to show us the results like this. If
So
you,
so for
yeah,
so for our for Thevenin's question, we have to print three times for RTH, VTH, and normal Thevenin circuit, and
yes,
same for the Norton so right?
yes, exactly. You got it right. Okay. Understood now?
Yes, sir.
Okay. Now let me show you once other steps also. Then we can proceed ahead. So is this clear what is expected from you all for RTH? Now, can we go to VTH now, everyone?
Yes, sir.
So if I want to, if I want to copy the same content of the entire, I don't want to repeat this circuit again. So what I will do is there is a copy button, just completely copy it and click on the new schematic. Entire contents will be copied onto the new schematic as it is. Got it? So now I can edit this document for VTH. So I can write over here for finding VTH, we need to remove RL and or measure VTH, or we can call it VAB. All right. Other things I'll remove it because it's not required because I'm finding VTH now. Can we start with VTH now?
Yes, sir.
So for VTH, what do we do? Tell me. We remove load RL and we measure the voltage between point A and B, correct?
Yes, sir.
So I'll need to put everything back, what I've removed. So that means I need to put my voltage source back over here. Then I need to put my voltage source over here also. Then there is, I think, one more. Yeah, this thing is there. Current source is also there. I'll add it over here. And A and B, I'll keep it open circuit only, right? Like this. Let me quickly connect them together. Yeah. So for VTH, this is how I do it. I only remove load RL. That's it. And I measure the, voltage between A and B, VA, VB. Let me give the value over here again. Again, don't forget to give the value. Or what you can do is a smart strategy is first do VTH and then do RTH. In that way, you won't be able to add this again and again. No need to add this again and again. I'll do it in Norton's theorem. Okay, this value is 4. So all of you ready? We need to measure VAB and Ltspice will give you directly that value. Those who are doing along, are you all ready?
Yes.
I mean, okay. Now if I go to simulate, click on run, I will get the value of V of A. Why V of B is not coming? Because V of B is directly connected to ground. So VAB is nothing but V of A. And that is coming out to be, as you can see, minus 18.814. Let me see over here. Yeah, see, minus 18.804 I'm getting in theoretically. But in LT Spice, I'm getting it as minus 18.8148. Did you understand this? Did you all get the result same? Those who are doing it. So let me write over here VAB or VTH is basically V of A minus V of B. But V of B is actually 0, right? V of B is 0 because it is grounded. Okay, so this is same as V of A, which is nothing but minus 18.8148 volt. So this way we can write. In this case, it is coming this way, okay? And then if you want to take the print screen, I'll push it over here and I simulate it. And I show this value that V of A is coming this much. Highlight this and then take the print screen. And then attach it in that Word document where I'm submitting. Got this? So this will show you the value of VAB. So VAB or VTH is minus 18.81 as shown in the theory. Yeah, we got it at 18.804, but that is okay. Did you all understand this, or do I need to repeat something?
No, sir, we understood.
Understood.
Okay. Okay, great. Now, how to calculate load RL? I mean, current to load RL. Anyone? Thevenin's equivalent circuit. Okay, so you have to make this
VTH,
circuit now.
RTH, and RL.
Exactly. So I'll quickly create a new schematic. Let me close this. Or else I can create a schematic here also, no problem at all. I can create it that down. So I'll connect over here. I require VTH. So this is my VTH. Then I require RTH. So we know not Thevenin's equivalent circuit. This is my RTH and this is load RL. Let me show it to you. Yeah. So now I'll connect them together. Okay. Then I'll connect the ground also because it's required in Ltspice. All right. Now what is my VTH value? Anyone? Minus 18 points. What? 8148. Correct.
8, yeah, 8 and 4.
And this is 6 point never ending 6, right?
667.
So, yes.
Yeah. This is I label it as RTH. Okay. I have to label it as RTH. This I have to label it as VTH. And this I have to label it as RL. Now, what was RL in a numerical? RL was 20 ohms. Okay. And this will be 20 ohms. Now what should I do? Should I simulate the circuit? Yes. So I simulate the circuit and I find the current. Now, in this Thevenin's equivalent circuit, both RTH and RL are connected in series. So current flowing, any of them will be same. Okay. So let me simulate. Click on run. If I check this, see I of VTH is 0.7. See this? Correct? Current flowing through this VTH, I mean, entire circuit will be 0.7. See, I of RL. This is I of RL. This also 0.7055. Did you get it?
Yes, sir.
Yes, sir.
And in theory, also we got the same value. Let me show it to you. See, I of 20 ohm will be 0.705. Now, obviously, it will be negative. Okay, and we are getting positive. It's absolutely fine. So, in order to get the correct value, what do we do?
So, 0
Add a
voltage.
voltage.
Yes. So I'll drag this, click it over there. Then I'll delete this wire. Add a 0 volt voltage source. Okay. Let me orient the direction. Yeah, like this. So I assuming that the current is flowing from left to right. If it comes negative, then the current direction is opposite. Let me call this voltage as Vx. And this value is 0 volt. Okay. Now, if I simulate this, I'll get the correct value of current. I of Vx. Did you get it? See? Minus. And in theory, also we got it minus. Understood now?
So when do we know that R value is minus or not?
From theoretical value.
Okay, so first we have to solve it in theory, then we have to put it in this. Ltspice.
Exactly. Yes, that's what I'm doing now. I'm showing you a solved example, right? So whatever I'm doing over here, you have to do it in your books and then compare the result. So if my current is coming negative, that means in Ltspice also it should come negative. So this is how I'm getting it negative. Understood now?
Yes, sir. So how much time do we have for this IA?
1 week.
Okay,
So
then it's fine.
yeah, it's plenty of time. Here you can write again all those things, and you can write here Thevenin's equivalent circuit. And I mean, you can express yourself by writing all that things. Thevenin's equivalent circuit. Only thing is the value should be correct. Whatever you write over here, the value should be correct. So you can simulate. I'm just showing how to, add a print screen for this type of circuit like this. Highlight this part, attach the print screen like this. Got it?
Yes, sir.
Now let me show you the actual IA document. All the divisions have received it or what? Someone has not received it yet.
So C5 में
Yes,
दिख
sir.
नहीं रहा है.
Yes, sir. You
Okay.
can see.
Who is your? I mean, okay. I've informed all the class teachers. They will upload it soon. Don't worry. You will get 1 week.
Sir, even C6 is not.
Okay. It's more than enough
Yes,
time
yes,
to
yes, yes.
solve this. You can solve this easily. I've uploaded in my classroom C3. I'm sure others have also uploaded it. So if they have not uploaded, you will get sufficient time. Don't worry. I mean, I have done it. We have done it together in half an hour. So it's very easy. Don't worry about it. Okay. So let me show you something over here. Let me open the Word document. So this is your IA number 1 for C1 to C7. I want to show you this parameters. So this table at the end you need to add. Okay, this is what I will take it from here. So this table I'll add over here and you write the practical and theoretical value. So what was the value of theoretical value of VTH? Minus 18 point. This way you need to write minus 18.804 theoretically I got, and simulated I got minus 18.814 volts. At the end you have to write this table, add this table. Got this? Then Thevenin's resistance was how much? 6.66. Yeah, over here. So I write over here 6.6667 ohms. So you can insert your symbol of ohms like this. And simulated also will be 6.667, exactly the same. Okay. And current value, how much did we get? We got this one. This is the load current. So minus 0.705. Theoretically, we also got it as minus 0.705. And in simulation, we got it as 0.70555 amperes. So we will check if the theoretical values and simulated values are all correct, you will get your full 10 marks. Is it understood how we are going to check this? And all this print screen should be attached. Got it?
Sir, till which decimal should the point should match?
Up till 2 decimals, it's fine. But
Okay, sir.
I am telling you, it will match up till 4 decimals also in some cases. But up till 2 decimals is fine. Okay, because what happens is when you solve it in a calculator using a calculator, some people take up till 2 decimals, some people take it up till 4 decibels. So answers might slightly differ. So that is fine. But simulated values will be very accurate as I have shown over here with this example. Okay.
Okay, sir.
Okay. Now you tell me whether I should show you Norton's theorem also, only the Norton's current, because the value of Rn or Rth is same. The calculation is same, and also the Norton's equivalent circuit. So you want me to do one example for Norton's theorem also?
Yes, sir. Only the IN one part.
Okay, because question number 1 is Thevenin's, question number 2 is Norton's, this one. So I will show you another example of Norton's theorem. And then if you have any doubts, you can ask me. Okay. So I'll quickly do that now. Let me open a document where I have a Norton's theorem. Let me select. Okay, I hope this will be your Norton's theorem. Yeah, we'll just do simple example. This will be quick. You just want to learn
Sure,
the
sir.
technique. Yeah, okay. So I'll show you all the steps quickly. It's fine. There will be revision for you all also. Let me show you all the steps for Norton's theorem. Let me delete all this and let me open a new schematic. Okay. Now I'll put the half screen like this, and other half you can see the diagram. So we need to find in the circuit current flowing through 4 ohm resistance using Norton's theorem. So actually by using Ltspice, you can make sure that the answers are always correct. Why, you know? First simulate in Ltspice, whatever numerical you got. Now, whatever answers you got, now solve it theoretically. And if you're getting any deviation, that means you're going wrong. So Ltspice will make sure all the results over here, whatever you get, will make sure that you never go wrong. I mean, you're understanding, right? Don't do it other way around. So first simulate the circuit, note down the values if you do it correctly. If you do it incorrectly, then both will be wrong. Okay. Now let me start building the circuit. So I'll go to component, current. I'll do it quickly. I'll rotate it. Then I require one more current source over here. Then I'll require a register. If you want, you can just watch it. I mean, since we are doing it for 1 hour, you can just watch this, or you can do it together, no problem. And then I connect the load over here. Now I'll connect them together with the wire. Okay. If it goes out of the screen, then drag it back like this. Now I feel the circuit is too crumbled. So what I can do, I can use this drag and drag this voltage source above along with this entire wire. Okay. Then drag this voltage source also above. Now the circuit is looking a little clean. I'm just remaking the circuit shown on the right hand side of the screen. I'll also add the ground. Ground is compulsory. Even if it is not given in the circuit diagram, you need to add the ground to the common point. Okay. Right click over here, 5 amperes. This will be 2 ohms. This will be 6 volt. This will be 2 amperes. And this is my load RL 4 ohms. I don't know if anyone is following, I mean, doing the steps with me. If you all are ready, can I proceed? Hello.
Yes, sir, you can proceed.
Okay. Now, first I'll measure ISC or IN, Norton's current. Okay. So what do you do for Norton's current? Anyone?
We short circuit the RL.
Yes. No. First we remove RL and short circuit terminals A and B. Correct?
Yes, sir.
So remove RL and then you can write over here for clarity, short circuit terminals A and B. So first of all, we have to write the A and B. So this is terminal A. This is my RL, right? And this is B. Okay. So for the first step, I'll remove RL. This is my load RL, remove it. And what I will do, I'll connect a wire, right? Like this. Correct? Hello.
Yes, sir.
But this you do it in theory. If I want to measure the current, listen carefully. If I want to measure the current across this, load A and B, what will I do? If I do this, I will not get the answer. I'm telling you.
So we have to add a voltage which will act as emitter.
Absolutely. We need to add an ammeter between that so that I can measure this short circuit current. So what I will do is, theoretically, it's fine. Theoretically, you find it this way only, but I need to add an ammeter. Now we don't have an ammeter. We have a 0 volt
Voltage.
voltmeter. So we have this voltage source which should act as an ammeter, 0 volt. I'll calling it as Vx. So current flowing through Vx will be my ISC, short circuit current. Got it?
Yes, sir.
So I'll do it quickly. It's already some time. So go to DC operating point, click on OK. Yeah, I got the current. See, plain and simple. What is the current? 4 amperes, correct?
Yes, sir.
Yes. And see in theory how much we got it. See, 4 amperes. Very simple. Okay,
Okay, sir.
understood the technique?
Yes, sir.
Any questions up till now?
No, sir.
Okay, so I simulate this. What you need to do is you need to add the simulation screen here only. I highlight this part and then take the print screen. So this is my Norton's current. Or you can write it, or what you can do is you can copy this by Control C. This Vx, I of Vx, right click, draft, go to comment, add it over here. And we can call it that this is my IN or ISC, which is equal to 4 ampere. You can write it like this. It will be much clear. And then you simulate. So those values over here, expand the screen, highlight it, and that is what we are expecting. So this way.
So
You
we
can
don't
attach
have
it
to.
in.
So we
Yes,
don't
yes,
have to
ask.
upload that book picture, the written theoretical part in the Word doc.
No, 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 no. Listen carefully. Yes, in the Word document, you let's say that you have written this. Let's say this example. You have written this, solved this question in your books, right? So you need to take the print screen, picture of it, and then you need to attach those pictures over here only in the Word document. So just the way I've added over here, see? So in this case, in your case, it will be a handwritten thing, correct? So you need to add those pictures first, then Ltspice print screen. You can write over here, Ltspice print screens. And then at the end, you need to add the table. So after doing all this, you'll get your full 10 marks if the answers are matching. Now I wanted to show your Norton's current. So this is how you find the Norton's current. Okay. Plain and simple, very, very clear it is.
Okay, sir.
Okay. Now let me show you all Norton's resistance. How do you find Norton's resistance?
The
Anyone?
same way RTH.
Correct. Exactly the same way RTH. So what I will do is I want to make a new schematic. So I'll minimize it a little, zoom out, click on the copy the entire circuit into a new schematic. Like this. You can do it like this, or you can modify the same circuit also. It's fine. Now we need to find Norton's equivalent resistance. Equivalent resistance. We call it RTH or RN. That's one and the same. RN or RTH. It's one and the same. So what do we do? Remove load RL and deactivate all sources. Correct? Yes. So this is my load RL. I have removed it. Okay, tell me what will happen to the sources.
The voltage sources will be removed and short circuited.
Okay, this is short circuited. Actually, the answer here, this numerical is very simple. So we can actually directly, get that value. No sweat. Like this, see? This voltage source, I have removed it, replace it with a wire. Okay, and there are two current sources. I'll just remove it, open circuit it. Now tell me, what do I get? What is my equivalent resistance? Can you not see? It's how
R1.
much it is?
Yes, sir.
Exactly. Exactly.
2.1.
Now, even if I want to connect a voltage test source, you can do that technique. You can connect a voltage source just for the, formality. Call it Vx. And let me say that value is 10 volt. Okay. Now we know the current will be around how much? The current flowing through R1 will be 5. Okay. So what is my this thing? I of Vx is 5. And what is Rn? Equal to RAB equal to 10 volt divided by
Right? 2 volt.
5. 2 amperes. Oh, sorry, 2 ohms. Sorry. So this is how I can present the Norton's equivalent circuit. Now, this is what you need to do. This is a very simple circuit, so we can directly get 2 ohms, but sometimes the circuit won't be as simple as it's shown over here. So in those cases, you need to add this information, okay? So you can show
Okay,
over here
sir.
like this. Yeah, like this. I'm just doing it for, once for all the documents. So save this file and save the print screen over here, like this. Got it? Clear? Now what do we do next? Last step.
Equivalent circuit, Norton's.
Yes. So what all things are there in Norton's equivalent circuit? We have a current source. What is
A
the direction
voltage
of the
source,
current source?
upwards.
Opposite.
Okay, opposite. So select this, opposite. Then we have Rn and then we have RL, correct?
Yes, sir.
Yes, sir.
Yeah, this is the last formality step. But in your case, it's very important. Even small things are very important. So I'm not missing out on anything. This is the ISC, or you can call it IN. Okay, what is the value of ISC which we got? 4 amperes, right?
Yes, sir.
4. And the value of RTH or RAB? 2.
2.
2.
And in the numerical, what was the value of load RL? 4 ohms, right? 4 ohms. So we need to add the ground.
Yeah.
So here is the ground. Sorry. Okay. So we have added the ground over here. This is Rn, Norton's resistance. Oh, sorry. And this is RL. Okay. Now we need to find the current. So simulate it. We need to find the current, simulate it. Yeah. I of RL is how much? 1.333. See, 4 by 3 is 1.33, right? Hello.
Yes, sir.
So this is what we get. And you need to add your answer like this. Let me put it properly. Okay, so this is you describe it, what we are doing over there. So this is Norton's equivalent circuit. Okay, and after simulating, what did I get? I of RL is 1.33. Let me copy that. I'll go to comment. So this is IL load current will be equal to 1.333 amperes. You have to do all the things which I'm doing over here for proper clarity. So I'll shift it on left hand side, added the simulation results over here, and highlighted this part that I have simulated this. Then take the full print screen and then attach this over here in the Word document. Okay. So this is Norton's equivalent circuit. This is equivalent resistance R and Norton's equivalent resistance. And this is my Norton's current. Got it? Hello.
Yes, sir.
Do you have any doubts? Okay.
Sir,
Now,
actually, I'm not
yeah.
able to.
Hello.
Actually, I'm not able to connect the components with the wires. Like my wires are not appearing.
Okay. So in your document, this one, there is no this notation is not there. This symbol
No,
is
it
not
is
there.
there, but when I
Okay.
connect it, it does not appear.
Okay. Just let's come to it. Let's come to that thing. Just wait. Let me complete this, then I will come to your doubt. Okay. So after your Norton's current is over, you need to write the theoretical values also over here. So this is, in our case, we are getting exactly the same, like this. Okay. Norton resistance was 2 ohms. So we got 2 ohms everywhere. We can insert the symbol of ohms. Here also we got it 2 ohms. So if these values, simulated values and the theoretical values match, then we can say that our numerical is correct. Okay. So in this way, you need to answer your question. I think odd and even roll numbers will have Thevenin's and Norton's theorem differently. So I've showed you entire steps for Ltspice for solving Norton's and Thevenin's theorem. All right. Now, if you have any query, you can ask. My Ltspice training session is over. Yeah, someone was talking about the wire, right? Let
Yes,
me
sir.
turn off the recording.